All right. I believe we are live. I can hear myself because I haven't muted a tab. That's always fun. Well, welcome, and happy Thursday. Welcome to another episode of the NATS IO Community Office Hours. Today, I'm joined by Maurice, which I'm super excited for our discussion. This has been, we've gotten to chat a couple of times, and it's been a really nice... Maurice is similar to myself, is newer to the NATS, but came from the open source community. And we've gotten to catch up a couple of times, and I just love his story. So we're bringing him on this morning. We're going to talk through a little bit of his projects, what he built with NATS, and kind of how he got into the community initially. And we're also, as always, open to answering and discussing any questions y'all might have. So please, if you've got any questions, put those in the chat. We'll probably start with a little bit of Maurice's background, but then I'm going to be keeping notes on him. So whether you're watching on YouTube or on Riverside, thank you so much for being here. And we will be, like I said, I'll keep track of the questions, but especially anybody here that's using Java, that's using the Java SDK. Maurice is a core contributor on several components of kind of the Java client and the NAT server, and quite a bit in the open source side of things. So if you have questions there, this is a particularly proficient expert that we're joined by this morning. But yeah, Maurice, you wanna give your short intro, and then we'll kind of dive into a bit of the background?
Yeah, for sure. So, hi, I'm Maurice. I joined Synea exactly 1 month as of today, so that's pretty cool. I've been using NATS for the past years, also in my previous employer, mostly backend dev / software engineer. And before joining Synea, I was also a teacher at a university, but now I've fully joined using Synea full time. Yeah, that's about it.
All
Oh,
right.
and I'm Dutch, which might be an interesting point to mention as well.
Yes, this is. Thank you so much, by the way, for joining me at your evening, because I know that it is not. Yes, time zones are a thing, and it's the cool part of working at a global, fully remote company. But it's also can be challenging to coordinate those schedules, and so we're very grateful that Maurice is making the time, taking time out of his evening. And then oh goodness.
But we're very coordinated, right? Because you just had breakfast and I just had dinner just before this. So
Yes. So I may have already screwed up one thing. Well, we're not live on the YouTube channel, and that is something that has been an issue in the past. So let me verify that and see. Okay. Well, yeah, I'm not seeing us live, and last week this was the exact same setup, so don't know if we want to debug that right now, but unfortunately we may not have the YouTube live direct upload. We will have the recording from Riverside, so we can go and re-upload to YouTube in the future. Yeah, we just redid the connection last week, but anyways, I digress. We can go ahead and hop into it there. Yeah, I don't think there's anything to be done right now. You don't see it live on YouTube, right?
no.
Yeah. Okay. Well, I'll figure
No
that out
worries.
for next week. But yeah, so I'd love to hear a bit. So you kind of mentioned, you were using NATS. Now, was this the first open source software that you really got involved in and kind of really, even thought about contributing with? Or had you done more open source contribution in the past?
No, for sure. Like first contributing to the Java client and also a little bit to the server, like half a year, almost a year in. But definitely my first more committed open source contributions. And I guess I technically did an open source contribution in terms of I like created an issue on for sales Next.js, but that doesn't really count. But so Nats was definitely the first actually working on it more instead of just creating a one-off issue somewhere. But yeah, so yeah, pretty much using NATS. Previous employer, we're working on architecture rebuild, and we're using RabbitMQ at the time.
Mm.
and pretty much looking at like what are the options. Um, so looking at RabbitMQ, which also has a streaming offering, and Redis and NATS, and I knew at the back of my mind there's also Kafka, but it was like, please let's not go there with like all the horror stories I've heard. But oh well. Um, but yeah, at first didn't even know that NATS existed. So really happy that we were also kind of transitioning to a more cloud native space. So I was also kind of eyeballing the CNCF page and noticed NATS there. So that's kind of set off this domino effect of looking into NATS, really liking it. Yeah, and in short, we're mostly going to use we're using like Jetstream and replication, so pretty much a 3 node cluster, not that fancy in terms of topology, but like 3 nodes. We were coming from like this 1 node RabbitMQ setup, so it's already quite an upgrade. Um, yeah, and pretty much building the new architecture on top of NATS. Um, yeah, and I cannot share that much about the like specifics of what we did, but
Sure.
just for background, like it was Jetstream, like 2 or 3 replicated streams, one getting like the initial set of data, which was pretty huge. Then there were applications that were pretty much event driven and generated events, and then also other applications like triggered based on those events, and you can kind of imagine this kind of setup. Um, and we were, of course, using the Java client. It's also where my kind of entry point started. And it's not necessarily possible to write software without bugs, I guess.
True.
So we encountered some in the Java client, but also on the server. Um, uh, yeah, and at the point where you're like building these new things, and you want those things to work. And I'm not sure. I can't like. This is just like 2 years ago when we started with NETS, when I started looking at NETS as well. So I'm not sure how I like what was the tipping point of me like looking into an issue for real, but we were like stumbling on this issue in the Java clients, and the issue was already open for some months, I think. Just kind of looking at, hey, has somebody looked at it yet? Kind of that kind of vibe. But it was very important thing for us to fix. So and of course, like me working in the company that I worked for, but also of course people working for any company, you're probably you're busy, and it's well, it's important, but it's like one another thing somewhere on a list to be done, but maybe not with the immediate trial, which I definitely get. But that's I kind of use that as a trigger to look into it more, because like using the Java clients, I knew which error messages that I was getting, and that was pretty much a nice starting point to see like where an application is, or where the like Java client library is this good, is error message being hit, what is our use case and how are we using it, and what should happen, that kind of thing. And then kind of just started digging. And I don't know if I should call myself lucky, but at some point I actually found the issue. So that was really nice. So I could actually also start contributing. And that was, I'm not sure if that was my first PR, but there was one really nasty, like multi-threading issue.
Gosh.
Um,
Race
and that,
conditions.
yes, it was actually the race condition. So it was to do with if I remember correctly, it was like if you're pushing, uh, it was particularly hard also to get into because you needed to have a certain throughput of messages and also a certain size.
Oh,
And if
right.
the client buffers those messages and sends them in batches to the server, so there was this nasty case where if you had a message that would like overflow the buffer, so it would not be included into the initial batch, then there would be some calculations in terms of like the message size, but it was done twice, once in like the batching side and once in another thread somewhere. And if those were sometimes a little bit desynced, and then something funny
Oh
happened.
man.
Anyway, it was, afterwards, I'm happy that that's figured out. But like where while you haven't figured out yet. It's hard to see what it is, and especially these kind of that's the fun part. Like things that are easy to fix are things that are hard to find.
Right. I
So
think
that's
that's one of the funniest, kind of trade-offs with bugs. It's a surprising paradox where sometimes it is the reproduction can be most of the work that goes into fixing a bug. And I think, yeah, as soon as like you mentioned the timing thing, and as I just think of all of the nightmare bugs I've encountered or heard about or even, helped others with, like probably 75% of them are race conditions. Like that is just the hardest class because it's that reproduction step can just be so, it's like, well, we know it's happening for certain workloads. We know it's happening for, it might be somewhat consistent, but that inconsistency just makes it so hard to track down. Like, okay, there's a timing conflict that's just like, a brittle thing. It's not a consistent breakage.
yeah, and even then, even if you're able to reproduce it, then still you're not there because then you still need to understand like, okay, what's
How do you
happening?
actually,
I know
yeah.
that it's happening, but why?
Right.
Um,
Then it's the actual, okay, what's the scheduling solution here? How do we, make it more resilient for out of order stuff, whatever it is.
yeah, that's especially kind of heartbreaking if you find out like it's just really silly. It's like a facepalm moment of wow, this is so stupid. But it took so much time. But yeah, no, that's kind of in that way. I kind of started looking into more doing more fixes in the Java client. And at some point, the core maintainer, who's still core maintainer actually, for the Java client, wanted to recognize me. So I actually got sent this care package of swag. So I also got this shirt and a bunch of stickers. And well, it was really great. And like a note with my name on it. And like I mentioned it at the start, like I'm Dutch, so I'm like, I mean, I needed it to be fixed. I wanted to fix it, and okay, I'm happy that I'm getting this stuff, but it kind of goes over my head, I guess. Maybe it's also in my character, I don't know. But
No, I think
really happy about it, but also not necessarily realizing that that it's reality or something.
you think they weren't recognizing, what do you think was the reality not being recognized there?
I mean, like I am not recognizing that it's viable. Maybe it
Right.
might be a little sprinkle of imposter syndrome. I don't know, but
Well, I think that's core to open source. That's one of the things I like really attracted me to open source software in the beginning was the global collaboration is just so cool and how, I was in the web ecosystem at the time and seeing industry standard, JavaScript is its own bucket of things, but seeing like the standard libraries where people are like everybody's migrating to using this library and it's it's some dude and the middle of nowhere and just put it out into GitHub and then it picked up steam and you get all these people contributing. And the strength of that community I think is so big. So I love that Sanadia did like reach out and connect you and kind of recognize those efforts because I think even when technically I think engineers often will downplay their contributions or kind of assume like, oh, this is not that big of a deal, like this isn't that huge. But in open source world, everybody's volunteering their time. So I think every bit of contribution, like just the fact that somebody takes the time and has the intentionality to upstream something rather than just kind of patching their own code base or adding in their own workaround. Like there's so many ways to
let's
just
make a
kind of,
fork.
I want to get the job done. Yeah, I just fork it. I mean, I've done that we did that with projects early in my career back at UCLA. Like there was definitely times where we would just say, all right, we just need this one little change. We need this one little tweak. And it's easiest sometimes to fork it and say, we're just going to stick this, side version and kind of that becomes its own maintainability burden down the line. But it's just not the default position to always look for, let's find the contributing.md, let's look at their process, let's get into actually, help upstream this and help get a PR in rather than just fixing my problem and moving along. And I think a lot of maintainers and projects do recognize that too. And that's why I hope, you getting a gift bag with some cool items is not a super rare occurrence, right? Like I think across the OSS ecosystem, that when you told me, it's like, well, that's kind of the, a minor token of appreciation. Like that's sort of a low bar in my mind. But it is, I think, just recognizing the intentionality of everybody in the community and how open source projects grow too. Like, if somebody goes through the hoops and the barriers to land that first PR, there's a good chance they're probably going to stick around and at least be interested in continuing to assist, especially where things are overlapping with their use case and their projects or what their work is. But I think that's very humble of you to kind of say, I didn't understand why they gave me this. I didn't think it was a big deal. And I don't think you're alone there. Like, I think as engineers, we can look at the actual code portion of the task, which could be, less than 50 lines, like especially a race condition fix. It could be just a couple lines. But again, it's the collaboration, it's the process, it's the intentionality. Like, you do have to do a lot more to get stuff like that into an open source project. So props to you. And I think it's a cool story for anybody, getting started in software development and working with these open source technologies. I remember one of the first moments I got a PR landed early in my career, and I felt that kind of, wait, you can just do things. Like, it was a big light bulb moment.
I can do this. Oh my god.
Yeah, like, I've seen people land PRs in like React, and they're little docs updates, but it was broken, and just that fact where people are like, wait, I'm on the contributor graph for this massive project. And I really don't think it's as out of reach as a lot of people think. And I also think a lot more engineers are totally capable of open source contribution. So
Yeah, I think it's a combination. I think one thing that's I find myself doing like the past years, and also when I started like with these open source contributions, but now also while working at Snadia, it's kind of stepping outside of your comfort zone and realizing, like, even especially like in my first week at Snadia, just in general, I guess I have this dip of like imposter syndrome, like, am I in the right place? Can I do these things? But then at some point you realize, like, yeah, I can do this. I just need to kind of start doing it, and once I'm like on a roll, then I'll be fine. But I think it also helps that the NATS maintainers are pretty active also on the repository side, but also in Slack, because you can just, that's also kind of how I started, just sending lots of messages in Slack up to the point where it might have been annoying at times. but they are really responsive. So that really helped also to discuss, for example, if we were having some server issues in terms of, hey, can I help you as like the core maintainers of this project or product? Like, I have the knowledge that you need to fix it, so if I can help you in fixing it in some way, either in providing you with my knowledge in terms of what my use case is or how I'm using it, or that's really really valuable, I think. Where it's at some points I see it's sometimes too easy to just say, like, I have this issue, here's a really short sentence of what my issue is, and go fix it, and then complain after months it's not picked up yet. I've mostly seen that if you put in the time to, like, make, for example, a reproducible example, if you're able to, or like describe what your use case is and how you're using it, and also be responsive if they have like questions like, hey, what's your setup, or what version are you running? And most of the time you get like to the resolution pretty quickly, at least as far as like the release cycle goes. But
Right.
but yeah, for sure, that's really yeah, that's kind of where it continued as well. Like, it was, I think, this December of 2022, I believe, even, where I was still working on some fixes, and like New Year's Eve, I was chatting with the core maintainer, like, I have a fix almost ready. I'm going to make a PR.
Oh
That was
my
great.
gosh.
But
Yeah.
yeah, yeah,
Go ahead.
it's continued there from Java client, but also, like I mentioned, also some issues at the server, and I at that point, it was like early 2023. I couldn't read Go codes yet, so I was already like, quite often, if I was like watching the server repository, and if I would see a PR, then I would subscribe and like kind of sneakily look at it, like, what are they doing? But it also helped me in, like, I was becoming pretty active in Slack at that time, and answering questions. So kind of in doing that, even though I could not read like the code, I didn't know which features were coming in, and I could point
Mm,
people to the PR, so that really helped. But at some point, I wanted to like fix things in the server, so I was like, okay, I need to learn Go. So I went to that and like learned Go. I mean, that's also something like for me, it was just the obvious thing to do. If I want to contribute, I need to know the language.
Right.
But but I guess I'm also a little bit crazy. But well,
Well, I think it's another, you know, a lot more people are getting into it with GitHub. Like I think GitHub has been awesome in lowering the barrier of entry.
for sure.
Back in the day, it was IRCs and mailing lists and all these things that were a little more arcane to get into. Discussion was a little harder. And again, I mean, even in 2024, it does depend on the project, right? Not all
Yeah, for sure.
projects are going to be actively maintained. Not all projects are going to have the bandwidth to kind of accept contributions. You have a lot that are
Yeah,
what is it, BD4L or BDFL, kind of solo maintainers that are in charge of the project, and they don't always like taking on contributions, or they don't have the time to review things.
yeah,
But again, like you find that right community, find the right project, and I think what you're kind of touching on there too is something I preach a lot in 2024. But just learning from open source, right? There's so many brilliant software engineers out in the world that are just working out in the open, and you can look at inventors of different frameworks. Like that was kind of my background in web development, was just, all right, well, who's making, the most used frameworks and what does their work look like? But even with the community stuff, getting involved in the Slack, a lot of projects have Discords now. Like, I think it's so cool that if you're just starting out and getting into software development, you can go and find those projects and just hang out in these Discord servers. Some of them even have their meetings. Astro is a company that does this. Astro is a web framework, and they have a thriving open source community, and they do not office hours, but they have like some kind of weekly, stand-up type meeting almost. It's mostly people from their company. Like it's people employed by Astro. But then anybody from the community can join in. So you can just pop into their Discord calls and listen to them getting work done and watch the PRs and watch the discussions. And like, yeah, there's just so much you can learn from, like you said, just subscribing to PRs, subscribing to issues, like taking interest on the things where you don't know exactly how something's going to be done, or you're learning about that technology, that system, or even a new language. So that's just really cool. It's such a cool benefit. So let's talk a little bit about kind of how that, your journey into Synadia now. So kind of coming more to the present. How did that come about, and what's been your experience so far?
yeah. So quickly going over the year up till now. So like the contributions didn't stop. So more fixes to Java client and the server client, and I can imagine I heard this even so sometimes like my name comes up during certain meetings. I'm like, oh god. But they were like, we need to do something. So they at that point, but now it's us. But like Snedia wanted to send me pizza, and it like it being international, it's hard because I'm in the Netherlands and the lots of Snedia's in the US. So how do you like arrange that? And really, like long story short, I had before I moved, I have a new house now, but before I moved, there was a local Domino's nearby, and I said like, if you're going to do something, maybe give me a gift card. But well, they gave me a gift card, but it was a US Domino's gift card, so I was like, "Please, guys, take it back. Please use it yourself. Where can I send it to you?" Anyway. I also, and then actually, like last year in April, March, it was also KubeCon in Amsterdam, so pretty nearby, but I wasn't planning to go. So they had kind of this way of still sending me a different type of gift card by mail, and once I got it, I like put my shirt on, I held the gift card, I bought pizza from like this local supermarket, and I made a picture and shared it, and it was great. But yeah, and yeah, then going to like December of 2023, where I had this chat with David interview for RethinkCon, which was in January of this year. We're also talking about this and like my community involvement in a way, and then I was really like the idea of RethinkCon was just like seeing some things that Snea is working on, mostly like clients, like customer stories and people in the community. So I was like, hey, I'm going to be someone, just some guy from the community. But then it ended up like, no, I was the only one of the community, and I would be ambassador, and oh my God, that's like what I said. Like I don't really realize how I don't know. Maybe I'm too Dutch. Maybe it's just me. But yeah, then I got to go to KubeCon as well as one of kind of the perks. So really
Mm.
happy that I got to be there in Paris in March. It's also really funny where haven't been to like this KubeCon at all before that point. So really nice to meet up with the team as well. Also, I walked
I was
around
gonna say,
the.
had you been to a tech conference before, or was that your first tech
That
conference?
was the very first even, yeah. So
Because that's
so
a big
I'm
one for your
I'm
first.
I'm not that outgoing, so that's one thing. And then in Paris on my own, it was like when I went with the Eurostar, and when I got at my hotel, I was like, breathe, I can do this, I did it, I'm here. Let's go to the conference center, let's find the booth.
Oh, that
That
is
was great.
so cool, though. I love that, it really is open source can lead to so many life experiences. That's you landed in Paris at KubeCon, all because of this, finding a Slack, finding a page on GitHub, using a project, and caring enough to contribute back and push stuff upstream. Um, that's so
Yeah,
cool. I love hearing those kinds of stories, and you just end up somewhere you never would have expected, and it's like, yeah, that's what happens. And also, just again in 2024, it's such a distributed world we live in, right? And
hmm.
there's so much of that contribution from across country boundaries and across the world, across time zones. It's just really cool. So,
Yeah. And
um,
it was especially funny. Like I have these plushies behind me.
yep.
So I was walking around the CNCF corner store there, and I was just looking around like, what? I need to buy something. I need to bring something back home. So walking around, and at some point I looked down, and then I saw this really cute plushie. That's, so I saw Fippy, and I was like, I mean, I got to get this, and then there were more plushies. So I was like, she's pretty lonely all by her own. So I bought another one, and now I have two.
Nice.
That's it's really
That's
really great.
that's the
But
CNCF gopher, right?
yeah, yeah, yeah. And
Yeah, you're
there were also a ton of other plushies, but I kind of needed to hold myself back to not buy everything. But yeah, that was really great. And then
oh
then even then it was kind of interesting because like it's, me being from the Netherlands and like even maybe you don't just generally don't realize like with credit cards and debit cards, most in the Netherlands is debit cards. But I needed to pay with a credit card, and I don't have a credit card. So I was there at the booth, and I was really sad. Like I want to buy them, but okay, I'll put them back. And then
oh
I was kind of not necessarily crying, but just for visuals. I was crying in the corner somewhere. Like, what can I do? And then I reminded myself, like, I have this on my phone, credit card. And then really confidently, I walked back and, like, just give me a moment. I have to put some money on it, and then I can buy it. And it was, but yeah, it was really great. Great also meeting the team. And I guess that's also that's really where it started. Also, like, kind of the obvious next step would be joining Synadia and working on it for real. So I'm really happy that it's been a month now in working on the Java client. Also did some fixes for the server. Also working on a feature there, and also working on some other projects which are not public yet at the moment. It's, uh, but yeah, really, really, really cool. And it's very funny, but because most of the people I kind of already knew because I've seen lots of video. Pretty much every video I've watched, I'm like NATS' biggest fan. It might be obvious, but yeah, that's great.
well, I think that's the mark of a good community too, right? It's engaging with contributors, engaging with core maintainers, like having that having a really good balance on sort of the community and the core team. I think can make a huge impact. And not that
Yeah,
it's necessary or strictly better than anything. A lot of projects are more driven by the core team than outside, but yeah, it's thanks for sharing that. We're about halfway
yeah.
through the call here. I did see Frederique in chat. Hello, giving the shout out for the pizza lunch. We haven't had any questions yet. So again, if you have any questions, you have anything you'd specifically like to ask Maurice about, or even just general NATS questions, please let us know. But I think, Maurice, you had talked about a couple different patterns that you have used and found useful, and I thought it was pretty cool. So I don't know if you want to jump into kind of sharing some of those.
Yeah, for sure. Let me quickly share my screen.
And so, well, yeah, I don't want to intro yet. I'll let you lead into it because I don't know which one you're starting with, but
The easy one. So, like kind of an introduction into like what I said before, like we were using 3-node cluster, not really an interesting topology in terms of many clusters or subcluster or leaf nodes, just these three with all the apps connected to either of the nodes. And something that was important because we were working on this rebuild pretty much is that all these apps would they didn't exist yet at this point. So you just started with this empty cluster, and apps would be built over time and added to it. So one important kind of theme of this pattern in some way is testing, and how do you test the application. Also because we were at the time, like 2 years ago, when we started using NATS, it's a new technology, at least for us. And what are the ways, and how do you use the system in the right way? How do you kind of blow up the system? How can we prevent us from doing that, especially if we're like building this production cluster, and we're already live with some subsection of our services using NATS. And how do we not introduce a new service and then blow everything up and have a ton of impact? So one really nice thing of NATS is that it's this really tiny Go binary, so you can run it already with local development, which it's just if you're just over here on like your local laptop. So my laptop, there we go. But you can just have like your own NATS cluster with your own new like experimental app, and then you can just test it. And that already works really nicely. And if depending on if you like, if you, for example, pre-create the streams, or maybe you have some logic in your app itself that creates the streams. And actually, we have this wrapping library around the Java client, which would identify if the server it's connecting to is part of a cluster or not. So the application would see like, oh, it's only one node, so we can only use one replica for the streaming consumer. Whereas if it would like create the stream or consumer, depending on what it needed to do, if it was connected to the system and it was not yet, there was no stream or consumer yet, then it would create it on the fly. And by recognizing topology, it would know that what the replication would be. Which is also a really nice factor of NATS, just being able to do that. It's, wow. But it's really nice in being able to test it locally. But then it's still quite a large step in terms of like, I'm over here happy running locally in like optimal scenario, just testing maybe some events. And it's quite different if you now like stop this and start connecting it for real. And then you start replicating. And if you're just generating your own data, it might not be an issue. But if you're dependent on other types of events from other apps, and there's interaction there, and maybe there might be apps that can respond or like trigger based on your events, it's quite quickly can like escalate into an issue if something would go wrong. So just like I said, like you can have this local NATS system just for local testing, which you can have either running locally on Docker or just with the Go binary directly. One thing that I found really interesting is that you can actually add a leaf node to your cluster. So you can just add, for example, here, say I have a leaf node, and similar to like your locally running NATS, it's pretty much from the perspective of your application, it's the same-ish. The only difference being that you can now actually get the traffic from the cluster. So if you're dependent on a certain app generating events which you trigger on and then create different kind of events, you can actually listen to that traffic, and that's already done by default. So just by connecting a leaf node into the cluster and by using the same accounts, because there's isolation between accounts, so you need to ensure you're in the same account. Then you just get these messages. But there's one issue with that, because then, of course, if you start generating events and start putting it on a stream, then they will also still go into the cluster. So you didn't really achieve anything apart from, like, yeah, for sure, you're connecting to a different system, but in the end, NATS make sure everything's connected still. So it, from a connecting application point of view, it's although it's four servers running, it's still one system. So what we did was you can set up permissions to make this traffic go one way. So instead of the traffic going both ways, you can actually say, look, I only want this leaf node to get read-only access in essence to the cluster or to some, and that's pretty easy actually to set up. So if you only want to receive messages, so you say just I want to subscribe, I want to be able to get all the messages and just deny all on the publishing. And that already achieved this. So at this point, you're already able to not necessarily source from streams, and actually we did something different where because you have this like read-only separation, you can actually have the same streams both on the cluster and on the leaf node. So for example, say like you could have a stream that's R3 over here, and that captures, for example, orders subject. You could have the same stream over here, also capturing the orders, but because it's listening to just the core messaging and publishing onto this, your applications would still, connected to the cluster, would still get the acknowledgement from the R3 stream. The message that's just going over the orders subject would be passed on to the leaf node. And even though this stream would try to acknowledge back to the original, because it's read-only, it cannot publish back to the cluster, you have this way of kind of tapping into this data. And you might say, in terms of security, like being able to subscribe to everything, now you can just wiretap the whole cluster.
Right.
So you could say, like, you could tune this down to just be the thing that you need for example, the stream. And the nice thing about this is that now, because these streams are separate, you can actually, and you could also do this with sourcing, but we did it this way, where you can actually listen to this stream over here and actually put messages into there. And now you could compare the streams or see, like, hey, given like the production traffic, does my app actually work under those circumstances even before I'm going to connect it to the cluster? So this was really a nice way of like, while the app is still experimental and in flux now, what it's going to do, and while you have not settled maybe even on like the schema, you can just stop the leaf node or just recreate the stream and start up again. It's really a really easy and nice way to do this. And depending on what you need, you can actually already easily just connect the leaf node. Then you could already do this. And if you actually only want this one-way communication, then you just say stop everything and deny all of the publishing. And if you want to be a bit more secure and that you don't get these responses or replies to, for example, application chatting between each other and the inbox being responded to, they can deny the traffic as well. So that's really interesting, which also helped us at that point in testing the application and kind of still. And we didn't run it in production. We'd actually run it on a development environment, and then there the leaf node was connected. But you can also run it just fine on a production environment as well, and just have this one-way traffic in a way where you can just, if the app doesn't do what you want, you can just stop the app. And if at some point the traffic is too much, you can just stop the leaf node, and it doesn't have at that point any impact that it might have, which probably it doesn't because it's already separated. But you could just kill it, and then you're fine. So that's a really nice thing that's pretty easy to configure also.
Yeah, I think that's the cool aspect of this. It hits on, something that I am continually feeling with NATS, but it's that there's so much configurability out of the box that there's a lot of really powerful patterns like this that are really not hard to implement. So even just like the wiretap pattern, just having that catch-all subject, super easy to drop that in. And you started this with kind of like the local dev environment setup. But correct me if I'm wrong here, you could still do this in a local environment, right? You could have that leaf node just be a locally running server. And so it's still, it still gives you that possibility of, hey, I'm just doing a local environment here. And I have two questions here. So one, yeah, still just the laptop, right? I mean, that's the cool part is you're not needing to deploy additional infrastructure anywhere to enable this kind of use case.
For sure.
Now, one curiosity I have is setting up this one-way connection. Is this going to impact performance in the cluster very much, or is that anything that you would really need to worry about with the production apps?
Yeah, so it's definitely something first to try out. Like what we did was first we tried to like you can do stream sourcing or mirroring. And mirroring in
Right.
this setup would not work because if your app is going to like want to publish messages into the stream, that's not going to work because that's not a mirror anymore. So it would need to be a source. And I'm not sure. And I tried it out like 2 years ago, so maybe the performance is better, but and also maybe it's a combination of just the sheer amount of data we try to push through it.
Sure.
So
But the stream sourcing was a heavier operation in your experience.
yeah, for sure. So that has impact on just it has more impact on the cluster in terms of it needs to do the sourcing, and you need to have a consumer
Right.
in the cluster to actually do the sourcing for you. Where having just a light, this is a really lightweight subscription, so you don't really notice anything apart from just one subscription number being higher. But NATS is really built around this being
Right.
really scalable. So also the really large benchmarks you can get with like millions of messages per second. That's just this. So this is the littlest impact, if at all, you can have. And this also has the added benefit and also side effect because it's just core NATS and it's fire forget. You might miss messages on the leave node. But hey, we're testing. It's fine. We're not going for reliability. We're more going for like testing. And the
Right.
reliability is something that we would get if we're connected to the cluster directly. There's also so that can be a downside if you really want to test for the reliability, but then you probably want to connect. You either want to use source or mirror, or you want to connect to the cluster like directly. But the nice thing about it not being a source or mirror is that if the leaf node stopped for like an hour or a day, or maybe you like spin up the leaf node for testing during the weekdays and during the weekend you shut it off. Once it starts up again, it's because it's just core NATS, if I forget, it's not going to like flush the cluster in terms of now I need to do 2 days of catch up. So
Right.
that's also something to take into account, depending on what use case you're going for. But yeah, this is the most lightweight that you can get, and it's I don't want to say it's for free because nothing is for free, but it's practically free.
Right. It's still sending messages. See, that's what I was thinking is like theoretically, if you have high enough throughput of messages through your system where it's just this massive amount, like maybe that's going to have some small performance impacts. But in the general case, I feel like this is just such a lightweight because again, you're not
For sure.
adding additional infra. You're not adding additional components really. Well, you are, but it's like this sidecar component that is one way as minimal impact to the production system as possible.
Yeah, and especially if you like tune down these subscriptions to only be something that you specifically want.
Right. Yeah. And I was going to say that's probably the first step, right? Is going from a catch all wiretap to just kind of scoping things down a little more for what you're developing, what the experimental app needs to look at. You know,
Yeah,
most production clusters, I assume, I mean, not entirely. Of course, if you're doing observability or logging type stuff, like sure, there are cases where you'd want to get all of that traffic, but in a lot of cases, I figure that's kind of your first step. Is if you do have that massive throughput of messages where you're concerned about a performance impact, it's like, well, then you can just scope down. You know, you just use the subject, and that itself, again, because this is all just such primitive, low level core NATs. It's
yeah, it's
both
just
easy and
a
performant.
request reply in the end. So yeah,
Right. Yeah, it's literally just sending a few more messages out. So my second question here, and I don't exactly know how this would work, but I know like with work queues, for example, if you've configured something in NATS to be a work queue, would you be able to do this pattern? Because I know work queues have more of the you can't read only, right? If you're
yeah.
in a work queue and you read a message, you're acknowledging that message and taking it out of the work queue. So would this kind of setup just not be possible if something was a work queue in here, or how would you work around that?
Yeah, so if it's a work queue, then stream sourcing or mirroring wouldn't necessarily work because then if you're like your main input is the work queue and then afterwards you mirror or source it into another stream, that would not necessarily achieve something in terms of like the work queue would be emptied pretty much when the sourcing is complete. So you still
Right.
only have you never have a copy of data somewhere. Whereas with this approach, you can have one work queue, for example, in a cluster, and because it's just core NATS, you can actually still you would not know if the message is actually accepted into the cluster or into that stream because that's you're kind of bypassing that. But assuming like the conditions are right and it would be accepted, then you can and you're not going after full reliability for this case. Then it would work. So you could have a work queue in the cluster and then maybe recreate a stream over here capturing the same subjects. But now you can actually consume, in essence, the work queue you can consume it again. But in terms of like where the components and the assets are, they are separate. But like
Right.
technically, you can consume indeed the
Well, and it
same data
wouldn't
again.
be, and it would only be live too, right? So this wouldn't be
Yeah,
persistent anyway. You couldn't go historical, but if that, the green leaf node is online, it's going to be getting all of that just live.
yeah,
But that's cool. So with this denial pub, it would be because I wasn't sure how that would work with the work queues, but it would basically be a wiretap that's invisibly observing. So again, assuming they're both live when the message is sent, you'd get those work queue messages in the leaf node, but it would not send any acknowledgement back.
yeah. So let's actually also draw that a little. So let's say you have this is in the cluster, and then you have a leaf node over here. So this is just a request reply, for example, in orders dot I don't know, create it. There's a work queue over here, just getting those messages, and then you probably also have a consumer somewhere here, which actually let me actually draw it in a different spot. You might have a consumer over here actually listening to those messages. And then, of course, the stream responds to you saying like, "Hey, PubAC, I'm acknowledging to you that the message is persistent. You don't need to retry putting it in there."
Yep.
And if you copy this, and then let me also put that over here. So this is the cluster, and this is the leaf node. So with stream mirroring and sourcing, what you would do is, let's say you have the same or just a stream over here that might be with different settings. Then you'd say like, I want to source or mirror, and then it would be like this. So the application goes into the work queue, it gets persisted, and then the consumer that's used for the sourcing and mirroring gets passed through to the leaf node. And this wouldn't work because with work queue you have this limitation for the reason of it being work queue that you only want one consumer because you only want to like process the message once. So in this case, this would not work. But because this is just core messaging, you're kind of just listening to this raw publish. So even if that's also why I said like even if it's not persistent, you wouldn't know. And this is how we've set it up. So the message would just, by virtue of this stream also listening on this subject, will get
Right.
this. And even I'm now thinking about if you would want to be sure that hey, the message is persisted in the work queue, there's even an option for that. We didn't use that at the point. I'm not sure if it even existed at the point, but then you could use republish. So you could
Oh yeah.
so when the message is accepted into the work queue, it would be republished into a different subject. For example, let's say repub orders created, something like that, and then you subscribe not on orders but on repub. And with subject mac, then you can actually remove and drop the repub part, and then just go to just orders. So
Yeah.
there's lots of options there, but the important part is that you're not creating a consumer.
Yeah, yeah, because the consumer is going to be unable to view or receive any messages without doing that work acknowledged and thus knocking it out of the queue.
Yeah,
Yeah, it's again, it's a fascinating aspect of NATS as a technology is just there's always a couple different ways to achieve something. And we were talking a lot a couple weeks back on these office hours. We were talking about the replication and the sourcing and mirroring. So having a
yeah,
source stream And yeah, it was interesting to hear about that limitation with the work queues, where it was like sourcing is not going to help you in that case. And that was one of the difficulties. But I love how this pattern kind of gets around that, either through the republish or through the just kind of, read-only leaf node that you're adding in there. So
that was really, really cool, especially with the republishing being there now and the subject mapping. So you could, depending on what you're going for. So if you're wanting a reliable way of getting all the messages, then you use sourcing or mirroring, but then you'll probably not have a work queue. And if you're going more for testing and I don't need any guarantees, then you probably go with the one that we were using at the time, where you can just cut off the traffic. And if you want more reliability in terms of the message must actually be persistent in the work queue, then you could republish. But then still, you might, depending on connectivity, you might not get all the messages. But again, that's kind of the trade-off that you're making.
Yeah, and like a lot of things with systems like this, I think that is kind of the key. Is it's like there's always a couple different ways to do things, but it's important that you do have a couple different ways because of those specific trade-offs. And I appreciate how working with NATS, a lot of the trade-offs, even by like kind of the configuration options that are set up, and even even how the docs in some cases kind of talk through the different configurability and how to set up your streams, you really do get a feel for sort of, well, here are the trade-offs, right? What are you looking for in this Leaf system? Is it resilience above all else? Is it every message? Is it not impacting performance, the main you can kind of pick and choose. But yeah, this is when you were telling me about this, I just thought it was a really cool pattern. It was a workaround for that work queue. I think it was a question that came up a couple weeks back in the office hours. But yeah, because that was one of those cases where it's kind of I wouldn't have assumed it, at least initially, that the mirroring or the sourcing was going to kind of clobber your queue in a way if you weren't aware of how those things interacted. So we've got about 8 more minutes here. Light day on chat, so thank you for diving into the architecture with me, because I'm learning a lot. I definitely have a few questions, and I think you answer them great. But did you have another pattern or architecture you wanted to touch on, or
for sure.
Kind of start wrapping up.
No, I can start with another one. But one thing I want to mention as well, just in general, also with this pattern, but also just in general, like the really thing that made me go wow was you don't, like, if you're not going to do the republish, is like you don't need to change the consumer or publishing code to do this. The only thing that you need to enable is that you can have a leaf node connection and set up the permissions if you need it. But it was like, I think that's one of the things that made me go in love with NATS. It's just, you don't need to edit your code. But like the publisher and consumer don't even need to know. What? What? That's just great. That's just great.
Well, and it's a lot of just the nature of distributed systems too, is having that separation, having that architecture set up that way. In theory, it's definitely not always the case in real world projects, but in theory, it should be highly extensible, right? You should be able to kind of add on a lot of components like this, and not have to necessarily do major refactors of existing pieces. Especially in like microservices architectures, although I've had more experience with, and it is very convenient when there are major structural changes that, by the nature of the microservices architecture and how you've kind of divided the system into the components, suddenly there's just a lot less burden on certain pieces, right? It can give you that flexibility to move a lot quicker with different aspects. So that's really cool.
And kind of not necessarily an extension of that, but more using kind of the same set of applications. So again, like the 3-node cluster applications, generating events, consuming, and like event-driven streaming, all the fancy words. But the idea of this is that you can have just normally you might have, for example, a real-time stream of data coming in, you're reacting and triggering events, and probably you're scaling the applications as well. But one thing to realize here is that these applications are all living very likely on their own node. So each NATS instance is in a different node, maybe even in a different AZ or a different cloud provider entirely. Who knows? Depending on again on your use case. But one thing that we needed was okay, we have this real-time stream of data and we're triggering events based on that, but you must realize like we are not entirely sure if our trigger conditions are right, either because of context data or maybe just by nature of our algorithm not being perfect, or maybe we have a bug somewhere, who knows? But we needed a way of taking that original stream of data, being able to run these applications again, and then re-trigger the events, and then maybe do diffing on terms of events, or maybe we like I said with the other pattern, we have a new application that we're building. It's experimental. We already have a backlog of 1 year of data, so we would really like to have these events ready once this application is there. But of course, it will only receive real-time data, so you need a way of like replaying everything, which would be possible actually if you have a stream with 1 year of data in there. It would already be possible, but we had multiple gigabytes of data every day. And actually, we're storing multiple terabytes compressed in, not anymore, but compressed in S3. So just having it in one stream and being able to replay there, that was not feasible. But still, then you need a way of reusing this architecture with applications, with NATS. But how do you reconfigure this in a way so you can actually replay the data and collect the new events? And actually, it's pretty easy. So let's just say that instead of...
I was going to say, I think I know where this is going.
Yeah. So if you can just deploy all of these components on one node, and it also depends a little on how you've architected this. So at that point we were running in Kubernetes, so everything was a different pod, and all the pods were on different nodes, or maybe they're sharing. But if you're using a Kubernetes job, or maybe using Docker, or maybe you're installing just all of the applications on one node, then you can install all the apps there, and you don't even need the cluster. Actually, it is not really, you're not achieving anything with a cluster at that point. So then you can just simplify, make it one node, and you don't have any networking latency anymore because it's just local networking. You now have just only one node with Jetstream. You can, if you want to go fast, you make it R1 memory based. It's not going to be durable. It's also not the expectation that you can have if you just want to go fast. So this was a really nice thing with a little reconfiguring of where the application are pointing in terms of where NATS is, and you deploy them within the same instance. And the only thing that you would need is you now need a way to like fetch the history or backlog somewhere, push it onto the stream, ensure that you have a little back pressures in there, especially because it's memory based. You don't want it to go out of memory really quickly. And now you need some way of collecting those events at the end. And probably you already have this at some form because you're probably also already collecting them and maybe storing them even. So with just those two extra components, which you already have halfway, and kind of using that setup of your application being connected to NATS, and so just a little reconfiguring, you have this really high speed, you have these local networking, R1 memory, and now you can just, even if normally in real time it would take an hour or like a month to go through the data, now you can just go full speed through all of that and just generate events. With one caveat is that your applications need to be ready for that. So you would need to have your application need to be ready to do that. So you need the events need to be deterministic. So given the same set of input data, even if they're not received at the same time span, the same events need to come out. And that can be hard, but that also depends on how you architecture application. So if you have an application that triggers on a timer basis, that's not necessarily going to work. Then you probably need to do some extra effort to kind of create an event for every timestamp that informs the app of, hey, even though it has just only been one millisecond, actually it was 1 hour real time. Then you could still get there. But it's just really also something that's enabled, like at the previous company, and being able to add new context, add new components, add new logic, fix bugs, and then just regenerate the events and overwrite them. And it's really a superpower. And because it's all running on one node, you can even scale it and just do it in parallel. And
Right.
it's very cool.
Just do some horizontal scaling.
Yeah, it's really nice.
Oh.
But yeah, we hit just on time.
We were right at the hour. I do want to welcome Ed to chat. Saw Ed pop in here.
Nice.
If you do have any questions, Ed, feel free. But yeah, I think we're pretty much wrapping up here. Again, thank you so much, Maurice, for joining. I was hoping we'd have somebody with a really difficult Java question for you pop in today, but yeah, I think.
Yeah, I saw it. You said it in the email. I was like, oh god, can I do that?
Yeah, but this has been
better luck
great.
next time.
Yeah, no, thank you, and I will. I may have you on in a future office hours as well, since you've been so willing to jump in and help out. And again, welcome to Synadia. We're really glad to have you here. It's been really cool getting to know you, and just again, I think it is such a testament to the strength of open source communities, open source software, and open source development. And I love seeing stories like that where somebody loves a technology and is able to make that their full-time pursuit in ways that, 10, 20 years ago would have been a lot more difficult too. It would have been a lot less infrastructure in general, but particularly in the open source world. I think it was a path much more rarely walked by software developers. So glad you're here. Thank you again for joining me this morning.
Really nice being here.
And like I said, the streaming to YouTube seems to be having some issues with Riverside. It's now worked 1 out of the last 3 weeks. I thought I'd resolved it last week, but with the same settings, it didn't quite work.
Circling back to the start. It's a really nasty race condition.
Oh goodness, yeah. If it was a race condition, oh man. But yeah, we'll work on getting this uploaded in some form to the YouTube channel, so hopefully it'll still live there. I don't know if you can get in that live tab. Hopefully I can kind of upload a stream after the fact, but I will figure that out. And again, thank you everyone who is in the audience, who's joining us. We will be back next week. And I believe, do I know the guest for next week? I won't mention it right now. We'll figure that out. But yeah, we've been, this has been a blast to have, rotating co-hosts. And of course, I'm no Jeremy, certainly not yet, although I'm striving to take over more and more of his role, or what he was doing here. But having the Synadia NATS experts here has been awesome for me, just to feel like I'm not going to be able to answer every question, but as a company, Synadia, I think, definitely has the expertise. And so we'll look forward to seeing you all next week. And again, have a great Thursday, great Friday, whatever day it might be for you in your time zone. And Ed said, really having fun learning NATS, like the new API. I'm treating NATS as a database in its simplest form, a superb product. Thank you for that. That's yes, and I agree too. I think coming from a background, especially of very traditional MySQL, Postgres, a little bit of NoSQL stuff in there, a little bit of new age stuff. But other than that, like I've been fascinated by some of the use cases leaning on NATS as a persistence. Ed, I assume you're leveraging Jetstream there and doing a bit, but yeah, no, it's a really fascinating technology to be able to replace. Like I said, especially in like web dev world, very heavy backends, very heavy persistence, services nowadays, because you've got all the serverless stuff. You've got so many different options. But even if you're just doing a large MySQL deployment, there's so much that goes into that. And the power of NATS and Jetstream to be able to be kind of a one-stop backend has been really intriguing to me, because I think I haven't had that experience as much in my background. I'm very used to like RDBMS and seeing the things people are doing and seeing the ways people are just simplifying. It's just when it clicks right, when it does fit the use case, right? Because there's certainly not every single use case. There's certainly tons of places where you do want MySQL, you do want that RDBMS. But when the use case is right and you're able to replace multiple pieces of infrastructure with NATS, I just think it's such a return to simplicity that's really nice, where it's like we're removing pieces, we're removing layers, we're removing, maybe not removing abstractions, but like in a sense, in those use cases where you would be leaning on 1, 2, or 3 technologies to do something that NATS can do at its core, or core plus Jetstream, it is a very nice experience. And especially as an architect, I think that reduction of complexity is something that we all want to kind of keep striving for. And anytime we have fewer systems to worry about when it comes to deployment, when it comes to testing, when it comes to observability, like, yeah, I'm always very grateful when we've done with 2 systems what we could have done with 6. It's just like, thank goodness this now makes the whole world feel a lot more approachable and a lot easier for so many tasks. So, well, hey, with that, hope everyone has a wonderful weekend, and we will see you again next week. Take it easy.
See you.